Hi, this is Chantel. I'm going to talk today about section 1.5 from our college algebra textbook, and it's about linear inequalities. So linear inequality is an inequality where variables appear only to the first power, just like a linear equation. An equation is something that has an equal sign, right? Has an equal sign. An inequality has an inequality. So it has a less than or equal, a greater than, or a greater than or equal. Okay, so besides the fact that it's an inequality, it's also a linear inequality, so all of the variables are only to the first power. So especially often we have x, but any other variable that may be there, it's to the first power. Okay, so I wanted to talk about the properties of inequalities before we get going here so that the things we're doing make sense. So the first thing that we're going to talk about is the addition principle, and I'm going to start with an example. So let's say 5 is less than 7. Well, what if I add 2 to both sides? Just like an equation, you have to add, if you're going to add something to one side, you have to add it to the other. So we're going to say, let's add 2 to the left, and I'm going to add 2 to the right, and that means I get 7 is less than 9. And is that true? It is. So that's just an example, just kind of using logic and common sense, that the addition problem says that if A is less than B, some number A is less than some other number B, then we take some number C, we add it to both sides, A plus C is going to be less than B plus C. Okay, so we still have the A and the B, and we've added C to both sides. So we're making a rule here. So it's always true. Actually, we don't get to say that very often in math, that it's always true. It only happens if we have a rule. All right, so the multiplication property is a little bit more complicated than this because we've got two different situations. One is if C is less than 0, and one is if it's greater than 0. In other words, if it is negative. So for C greater than 0, we're going to be talking about something like, and I'll give you an example, if say 3 is less than 8, and we're going to multiply both sides by 2. So we'll say then 3 times 2 is less than 8 times 2. Well, is that true? Is 6 less than 8 times 2, which is 16? Yes, it is. So that's just an example. The rule is if C is greater than 0, in other words, if it's positive, if A is less than B, then A times C is less than B times C. And I should go back real quick and say this less than right here can be any of these things. Okay, it can be any of those things. Less than or equal to, and same with this one. I'm just using less than as an example, but this can be any less than, greater than, less than or equal to, greater than or equal to. All of those things are true in both of these situations. The next part of the multiplication principle is if C is less than 0. In other words, what does that mean? It means C is negative. It's a negative number. Okay, so if we're working with a negative number that we're multiplying on both sides of the equation, something different is going to happen. And I want to talk about this really quick. I want to give you an example first so that we can think about it. So if 3 is less than 8, then what? So if we're going to multiply both sides by -2 this time, then 3 times -2 is what? 8 times -2 on this side. So in this case, I'm leaving it blank because I want you to think about it. -6 and -16. Which one is less? So we started out with 3 less than 8, but now we actually have -6 is greater than -16. So when you multiply or divide by a negative, so the multiplication property also applies to division. Okay, it works for both ways. They have the same rules. So if you multiply or divide both sides by a negative, it's going to make it so you have to switch the sign. Okay, so the sign switches. So the rule is if A is less than B, then, and this is only when C is less than 0, then A times C is then greater than B times C. So we've taken C, or -2 in this case, times both sides. It switches the sign. Okay, next I have some examples to how to use these rules to solve some problems. So the first problem that we have here is 2t plus 1 is greater than 3t plus 4. So this is going to be solved as if there was an equal sign here. Okay, so just solve it the same way. I'm going to erase that because it's not equals, but just as if there were an equal sign. So we want to move this around so that t is on one side and the number is on the other, just like if there were an equal sign. So I'm going to say minus 3t, just because we're used to seeing inequalities with the variable on the left. And I'm going to say minus 1 on both sides. So over on the left I get negative t is greater than, and I get 4 minus 1 is 3. So if negative t is greater than 3, then that means that the opposite is true for positive t. But another way to think of it is I'm going to multiply both sides times a -1. So both sides times -1 so that t becomes positive. Okay, and when I multiply by a -1, the rule that we just saw right here is that if it's a negative number, then we have to switch the sign. So you can either think of it as a rule, or just, I would prefer it if you understood the common sense of it, is if negative t is greater than 3, then positive t must be less than negative 3, sorry, less than -3. All right, so that's the way we think about these problems. And if it's easy just to think, if the sign is negative, if the number is negative that we're multiplying both sides by, we have to switch the sign. Okay, so now we need to put this in interval notation. So what we're saying here is t is, and that's a terrible -3, I'm going to rewrite it, t is less than -3. So what we say there then is that it goes from -infinity up to -3. So that is an interval notation. Okay, the next problem we're going to look at, again, has a less than sign. So we're going to start by bringing all the x's to one side and the numbers to the other. But what you'll see right away is that if we subtract x from one side, if we say -x, it's going to subtract out of both sides, and you end up with a statement that says 4 is less than -1. Is that true? That's not even true. The x has gone away. We've got 4 is less than -1. We get something that is false. This is false. So that means that there is no solution to this equation. There's nothing that could possibly make this true. Okay, the next problem I'm going to work is number 18 from the back of this section, 1.5. So the first thing we want to do is we want to distribute the -3 to both of these things. And watch your negatives, be careful. You get -3x plus -3 times -3 is 9 is less than 7x plus 1. Okay, so the next thing I'm going to do is I'm going to bring my x's over to the left. And I'm going to get my number, my constant, over to the right. So the 7x subtracts out and the 9 subtracts out, and I get -3x, be careful with your negatives, minus 7 means we're basically adding the negatives, and we get -10x is less than -8. All right, so the next thing we're going to do is we're going to divide both sides by -10, and we get the -10 divides out here, and we get x is, and now we've divided by a negative, which is the same as multiplying by a negative when it comes to the rule. We're going to switch the sign because now we've created a different situation here, an opposite situation. X is greater than, now these two become positive, and we get 8/10. So remember, 8/10 is the same thing as 4/5. So x is greater than 4/5. So we're going to write this in interval notation. So that's greater than, so it starts at 4/5. It does not include 4/5, so we have a rounded bracket. And it goes up to infinity. And it never includes infinity. Okay, so again, with the rounded bracket. Okay, so that is our final answer on that one. All right, so I'm going to let you solve the next inequality. Move this up here, and you can back up and look at what I just did if you'd like to, but go ahead and work this and put your answer, x is less than or greater than whatever your answer is, in the box when you get the chance to do it. Okay, so here's the solution that you should have gotten on this one. You should get from negative infinity up to 2, in other words, everything less than 2. So I'm going to draw a quick number line here and show you that everything on here is going to be less than, but not equal to. So not equal to 2. I didn't draw that very well, but not equal to 2. So I want to show you how to check your answer. When you're doing work that you don't have an answer to, like on a quiz or something, how would you check this? Well, you want to find a couple different points to make sure that what you've done is correct, because often people will have it go up when it's supposed to go to the right when it's supposed to go to the left, and vice versa. So the first thing I'm going to do is I'm going to try one that should be true. So 1 is right here. There's 1 right there, and it should be true. So I'm going to plug that in. So I'm going to say I'm going to try x equals 1. So I'm going to plug that in. I'm going to have negative 3 times 1 plus 5 is greater than negative 1 plus 1. Okay, so I put 1 in every time there was an x. I've got negative 3 plus 5 is greater than negative 1 plus 1 is 0. So I've got 2 is greater than 0. Is that true? Yes, that is true. So that worked. So now 2 should not be included, neither should 3 or 4 or 5. So you can try any of those and see if they work. And I would suggest doing that. I would try multiple points, the point itself, if you want to, or something to the right or left of it, and make sure. So anything over here should not be true. It should not work. So I'm going to try 1. I'm just going to try 3. So 3 is right here. So I'm going to plug 3 in. Try x equals 3. So I get negative 3 times 3 plus 5 is greater than negative 3 plus 1. So I get negative 9 plus 5 is greater than negative 2. So negative 9 plus 5 is negative 4 is greater than negative 2. So wait, what? That's not true. I even confused myself for a moment there because I did it and I was like, wait, that's not true. Well, it's not supposed to be true. This is false. This is false. So that means that what we just found is not true, and it's not going to work. So the 3 is not part of the solution. So what we just did showed that our answer is correct for this particular equation. All right, and again, I would highly recommend doing that on a test or quiz. I'm not going to show you that every time, but that's how you check. And you might want to look back through that again. Okay, this next one is an example of one with fractions, which is really not a big deal. You just get rid of the fractions first. So we're going to multiply both sides times the least common denominator, which is 2. So we're going to multiply by 2. And remember, you've got to multiply this and this by 2. So in this first one, we've got the 2 is going to divide out, and we're left with negative x and is greater than. And we've got 2 dividing out on this one. So we get 3x, not 6x, because it multiplies times the 2 and divides out. It doesn't multiply times the top also. It's just 2 over 1. And then on the next one, we get 3 over 1 times 2 over 1, which is just 6. Okay, so we've got negative x is greater than 3x plus 6, and we need to subtract 3x from both sides. So the x's are on the left side. We get negative 4x is greater than 6. Now we're going to divide both sides by a -4. And what happens when we divide by a negative? The sign is going to switch. So the -4's divide out, and we get x is less than -6/4, which is the same thing as -6/4 is the same thing as -3/2. Okay, so x is less than -3/2. So what that means is we've got -infinity up to -3/2, and it does not include the -3/2. So that's our final answer. Okay. All right, so I'm going to let you try this next one to check it out too, and please put your answer in the Edpuzzle box. Okay, so your answer to this one should be -3/11 to infinity, or in other words, x is greater than or equal to -3/11. And you can pause here and take a look at what I did. Okay, the next topic we want to talk about here is a compound inequality. And a compound inequality is when two inequalities are joined by the word and. So I could say x is less than 5 and x is greater than 0, or something like that. So that is a compound inequality. You can also write it like this. So you've got a number less than some other things, less than something else. Okay, so for this particular problem, what we do to one of the 3 parts, we have to do to all 3 parts. So we want the x by itself, and it's right here. So we need to look at this area where the x is and think, what do I need to do to get the x by itself? Well, the first thing I need to do is add 2, and I need to add it to all 3 parts. So I have -4 plus 2 is -2, and that is less than or equal to, and what I have left here, the 2's are going to subtract out, and I get 3x is less than or equal to, I've got 2 on the right side, plus 2 is 4. Okay, so next what you want to look at is how am we going to get the x, again, by itself, and I need to divide 3. So when I divide 3 here, I have to divide 3 here, and I have to divide 3 here. Okay, so it's going to divide out and leave the x by itself, and that means x is less than 4/3, and it's also greater than -2/3. So we always want to put the smallest over here on the left. The smallest number is on the left, and we have the biggest is over to the right. So we kind of think left to right on the number line. So it's similar to the number line. We want to have the thing on the farthest left, and then the x in the middle, and the thing on the farthest right on the right. So the biggest, smallest to the biggest. All right, stop there and look at that if, in case that doesn't make sense, and then we'll move on to a little bit harder one. Okay, this one has a fraction in it, but no biggie. We just want to get this x by itself once again. So what do we need to do to this this part here, this whole part, in order to get the x by itself? Well, the first thing we need to do is we need to multiply everything, everywhere, all 3 parts, by 3. What you do to one part, you do to all 3 parts. So on the left, we're left with a 3 is less than or equal to, and here the 3's are going to actually divide out, so they're gone, and the top will just be 2x minus 1, and that is less than or equal to 4 times 3, which is 12. All right, now we're still trying to get this x by itself, so we need to add 1, and what we do to 1, we do to all 3. So the 1's going to go away in the middle, and we end up with 4 is less than or equal to 2x is less than or equal to 12 plus 1 is 13. Okay, the last thing we need to do to get this x by itself is divide by 2 so that it divides out, and we end up with dividing by 2 on all 3 parts. So we end up with 2 is less than or equal to x is less than or equal to 13/2. And we want to leave it as 13/2 instead of 6.5. It's just a little cleaner. So now we've got or equal to. So now for the first time we're going to see square brackets. So x is between 2 including 2 and 13/2 including 13/2. Okay, so I'm going to talk about a couple of examples of applications for these kind of problems, and there's lots of applications for these. And all of them are real life kind of situations. But this one is about Terminator 3, and it's a cost versus revenue, or revenue versus expense, however you want to look at it. But Terminator 3 costs $55 million to make and another $30 million to market. So you just have to, on these kind of things, you just kind of have to use common sense. But what I'd like to see everybody doing on these problems is not just trying to jump right in and do the problem, but please, please write all of these things here. It's really important, and it's really, really helpful. You need to know what your variables are in order to be able to work with a problem. So T is the number of tickets sold. C is the cost. And the cost here is given as 55 million and another 30 million. So we've got 55 million plus 30 million is going to be 85. And I'll go ahead and write the million there. I didn't want to write it every time. 85 million. So an average movie ticket costs $8, and only half of this amount goes to the studio. So that means $4 goes to the studio. Sometimes you need to add just a little bit more. How many tickets must be sold for the movie studio to break even for this film? So break even means, what does break even mean? So break even, and look at our variables, means that the revenue equals the cost. That's all it means. All right, so in this case, what is the revenue? Well, they're making money from tickets, and they only make half. So they basically get, the revenue is half of $8 per ticket. So 8 times every ticket, which is $4. They're making $4 for every ticket. Okay, so break even means that R must equal C, right? And that's 85 million. So how many tickets must be sold? And you want to set 4t equal to 85 million. So you're going to divide both sides by 4. And you get t equals 21,250,000. And that's it. That's all that one needs to have done. Just number of tickets is t. This last problem is about communications, mobile phone services, and 2 different plans that you're trying to choose from. So plan A charges a fee of $4.95 a month plus 7 cents for each text message, and plan B costs 10 cents per message but has no fee. So we're going to find, in A, we're going to find the total monthly cost in terms of the number of text messages. In other words, they're not looking for a number, they're looking for an equation. So A is going to equal the cost per month, which is $4.95 per month, plus 7 cents per text message. So we need to basically, I'm going to come up here and say M is the number of text messages. Okay, so this is, again, an important step. You need to pick a variable, make it up, something that makes sense. You could say N for number, or T for text messages, or I used M for messages. So down here then we're going to say, well, it's 7 cents for every single message. It's going to multiply times the number of messages. Okay, so that's going to be the cost of plan A. The cost of plan B, there is no base cost like $4.95. So B is just 10 cents per message. So it's going to be 0.1 or 0. I always forget the zeros ahead. 0.01 M, basically. So you could just write 0.1 M too. So 0.1 M. All right, so now that was the easy part. Now you have to think through what they want for this last one. How many text messages need to be sent per month for plan A to be cheaper than plan B? So you need to set A, cost of A, less than B. Okay, so this is the cost of A, this one is the cost of B, and so now we want to set A less than B. So we're going to plug in what we got for A, which is 4.95 plus 0.07 M equals, not equals, less than. We want to say less than. Equals is a habit, but in this problem we want to know what it's going to be. A is going to be less than B. So that's going to be less than 0.1 m, or 0.10, whatever's easier for you to see there. So now we want 495 to be on one side and 0.07, the m's to be on the other. We want the m to be positive, so it doesn't really matter how you rearrange this. In the end, you're going to have to fix the sign on it. So I'm going to actually subtract 0.07 m from both sides because I want you to see a new way of doing this. So we get 495 is less than 0.10 divided, or minus 0.07 is 0.03. So 0.03 m. All right, so now we're going to divide both sides by 0.03. That 165 is less than m. Another way to look at that is that you can look at this backwards and think, reading from the right, m is greater than 165. So it's easier for you to write it that way. Then you can do that. That means for plan A to be cheaper than plan B, which is what I had to just go back up and look one more time to make sure that's what we were doing. Plan A is cheaper than plan B when the number of messages is greater than 165. Well, you can't have half a message, so it's going to be 166 or more. Okay, so 166 or more text messages in plan A will be cheaper than plan B. All right, thanks for watching.